Hello everyone. In this lesson we are going to focus on limits and we are going to solve some limit rule examples. Let's start with the first example. Limit as x approaches c, x cubed plus 4x squared minus 3. It's equal to, let's continue here, limit as x approaches to c, x cubed plus limit as x approaches to c 4x squared minus limit as x approaches to c 3. And then this is c cubed plus 4c squared and minus 3. That's the answer for the first example. For the second example, let me erase this part. This limit as x approaches to c, it's a fraction, x to the power 4 plus x squared minus 1 divided by x squared plus 5. Let's continue here. It's equal to limit as x approaches to c, x to the power of 4 plus x squared minus 1 divided by limit as x approaches c, x squared plus 5. And this is equal to also limit as x approaches to c, x to 4 plus limit as x approaches to c, x squared minus limit as x approaches to c 1 over limit as x approaches to c, x squared plus limit as x approaches to c 5, and it will be equal to, this part is c to the power of 4 plus this part is c squared and minus 1 over c squared plus 5. That's the answer. Now let's go to the next example. Okay, this is the next example. Calculate the limit of given rational function as x approaches 1. Let's continue here. It's equal to, say, limit as x approaches 1, x to the power of 4 plus x squared minus 1 divided by x squared plus 5 is equal to limit as x approaches 1, x to the power of 4 plus limit as x approaches 1, x square minus limit as x approaches 1 divided by limit as x approaches 1 x square plus limit as x approaches to 1 5. This is equal to if we substitute 1 for x, then it's 1 to the power of 4 plus 1 to the power of 2 minus 1 divided by 1 square plus 5 is equal to, we can cancel this with this one, then it's equal to 1 over 6. That's the answer. Now let's go to the next example. Example 4, find the limit of given expression as t approaches 6. Let's continue here. Limit as t approaches 6, 8 times t minus 5 times t minus 7 is equal to 8 times limit as t approaches 6, t minus 5 times limit as t approaches 6 times t minus 7. If we replace t by 6, then it's equal to 8 times 6 minus 5 times 6 minus 7 is equal to 8 times 1 times negative 1, which is equal to negative 8. That's the answer. Now let's go to the next example. Find the limit of given rational function as x approaches negative 5. We can find the limit of this function using the direct substitution method. Then this is equal to, if we substitute x by negative 5, negative 5 square plus 3 times negative 5 minus 5 divided by negative 5 plus 7. Let's continue here. Then it will be equal to this 25 minus 15 and minus 5 divided by minus 5 plus 7, which is equal to 5 over 2. That's the answer. That's the most quick way. This is the next example. Limit as x approaches negative 3, x square minus 9 divided by x plus 3. How can we find the limit of this rational function? If we use direct substitution method, let's first try the direct substitution method to be equal to limit as x approaches 3, x square minus 9 over x plus 3 is equal to negative 3 square minus 9 divided by minus 3 plus 3, which is equal to 0 over 0, which is an indeterminate form of the limit theorem. So we cannot use the substitution method for this example. So we need to use factoring method. So using the factoring method, the numerator and denominator must be factored. Then let me erase this part. Limit as x approaches negative 3, x squared minus 9 divided by x plus 3 is equal to limit as x approaches to negative 3, x plus 3 times x minus 3 divided by x plus 3. Now the factor x plus 3 can be cancelled to get the much simpler limit expression of limit as x approaches negative 3, x minus 3, that can be easily evaluated via substitution. Then it will be equal to, if you use the substitution, negative 3 minus 3, which is equal to negative 6. That's the answer. Now let's go to the next example. This is the next example. Find the limit of given rational function as x approaches 5. Let's first try the direct substitution method. Then it will be equal to 2 times 5 squared minus 7 times 5 minus 15 divided by 5 minus 5. As you can see, the denominator here is 0. Also the numerator, let's check the numerator. It is 25. It's equal to 50 minus 35 minus 15 divided by 5 minus 5. It's also 0. It's equal to 0 over 0, which is indeterminate. Okay? Now we can use the factoring method. Let me erase this part. Let's see what will happen when we use the factoring method. Then limit as x approaches 5 to x squared minus 7x minus 15 divided by x minus 5 is equal to limit as x approaches 5. We can factor numerator as x minus 5 times x plus 3 over 2 divided by x minus 5. Now these will cancel out. X minus 5 divided by x minus 5 is 1. So it's equal to limit as x approaches 5 x plus 3 over 2. Now we can use the substitution method, which is equal to 5 plus 3 over 2 is equal to 13 over 2. That's the answer. Now let's go to the next example. This is another example. Evaluate limit as x approaches 5, square root x plus 11 minus 4 over x minus 5. Let's first try the substitution method. Limit as x approaches 5, root x plus 11 minus 4 over x minus 5 is equal to root 5 plus 11 minus 4, 5 minus 5, which is equal to 4 minus 4 over 5 minus 5, which is equal to 0 over 0, which is indeterminate again. So we need to find another method. So we need another method to find the limit, since the function probably has a hole at x equal to 5. To start, using the new method, multiply both the numerator and denominator by the conjugate of the radical expression square root x plus 11 minus 4. Let me erase this part. Then limit as x approaches to 5, root x plus 11 minus 4 over x minus 5. Now we are going to multiply both numerator and denominator by the conjugate of the radical expression root x plus 11 minus 4. The conjugate of a minus 5 is a plus 5, okay? Then multiply it by root x plus 11 plus 4 root x plus 11 plus 4. Then it's equal to limit as x approaches to 5 and x plus 11 minus 16 divided by x minus 5 times root x plus 11 plus 4. And this is equal to limit as x approaches to 5, x minus 5 over x minus 5 times root x plus 11 plus 4. Then it's equal to, these will cancel out, x minus 5 divided by x minus 5 is 1. It's equal to limit as x approaches to 5, 1 over x plus square root x plus 11 plus 4. And this is equal to, we can now use the substitution method, 1 over root 5 plus 11 plus 4, which is equal to 1 over 4 plus 4, which is equal to 1 over 8. That's the answer.